Hi, in this video we're going to teach you how to write UPAC names for hydrocarbons and also how to draw structural formulas from UPAC names. But first of all, what is UPAC? The UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization not affiliated with any government. The UPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. The UPAC was formed by scientists who recognized a need for standardization in chemistry. And why are UPAC rules necessary? UPAC rules are necessary because it is easier to have UPAC names than to name all compounds after something or to give them nicknames. Then it will be confusing. Because there are so many compounds, and if we want to know everything about some compound just by reading its name, we will use UPAC names to identify it.
A hydrocarbon is an organic compound that is made only of hydrogen and carbon atoms. It can be found in so many places, including crude oil and natural gas. Hydrocarbons are divided into four main groups: alkanes, alkenes, alkynes, and aromatics. Alkanes are organic compounds that consist entirely of single bonds. The general formula is CnH2n plus 2. Alkenes are hydrocarbons with at least one carbon-to-carbon double bond. Alkynes are organic compounds that are made of one or more carbon-to-carbon triple bonds. Aromatics are hydrocarbons with sigma bonds that can create rings.
Alkanes are a type of hydrocarbons that contain only single bonds, and there are 6 rules for naming them. The first rule is to identify the longest possible carbon change, that in this case is this one. Then, number the carbons starting from the ending closest to a substituent. After that, identify the substituents. Name the substituents indicating their location. At the end, name the pairing change. Separate numbers from numbers with commas and numbers from letters with.
Alkenes are organic compounds that are recognized by the double bonds that are present in their chemical structure. According to the IUPAC system, in order to name an alkene, you have to follow the same rules when naming an alkano, only with these differences. The parent change must include the double bond. The numbers must start from the ending closest to the double bond. Indicate the position of the double bond and change ending "-ane" to "-in". Example: the parent change must include the double bond, so this will be the parent chain. Numbers must start from the ending closest to the double point, so it will be 1, 2, 3, 4, 5, and 6. Then we can start naming the alkene. We have to put the substituents in alphabetical order. We have that these are methyl, methyl, and this one is propyl. So the M will go first. Number 4, comma, number 5, and we put dimethyl because we have 2 methyl. Then we add a hyphen and we put the other substituent. There will be 2 propyl. Then the next step is indicate the position of the double bond. We put the position, and finally, as we have a 6 carbon change, this means that it will be an hexane but the rule says that we have to change the ending "-ane" to "-in", so it will be "hexene".
Alkenes contain a triple bond between the molecules of carbon. In order to name them, we need to follow the next rules. First, start counting from the side closest to the triple bond. Then, name the substituents in an alphabetical order. If there are more than one substituent from the same kind, you need to use the prefixes. Finally, name the parent chain depending on the number of carbon atoms that it contains, and at the end just add the ending "-in".
Now, for aromatic compounds. Aromatic compounds are all those that include the benzene ring. The benzene ring is a 6-carbon chain with alternating double bonds. The rules for naming aromatics are simple. First, you have to identify the parent chain. You have to determine whether it's the benzene circle or a substituent outside of it that's bigger. For example, if you have a methyl sticking out of a benzene circle, like in this case, you're going to take the benzene ring as the parent chain. But if you have any other carbon chain that's longer than 6 outside of this, you're going to take that as the parent chain and the benzene ring as the substituent. One example for an aromatic compound is this, toluene, also known as methylbenzene.